Hi, this is Mr. Max. So I am looking into paper 2 of 2024, the AS level. This is 4 of 4 paper 2s. Right, let's go directly and start with this. Of course, I always say take note of the instructions and the information, especially the one that deals with, the degree of accuracy if it's not specified in the question and the answer is not exact and they don't tell you that you must write the exact value, then you will follow the rounding indicated here. That means three significant figures. But when you deal with angles, in degrees is one decimal place and in radians it's three significant figures. Now it's very important also that you notice that there will be a time where you will be required to change your calculator mode from degree to radians and back. Okay, let's start with the first question um, here. I say a curve has the equation y equals 2x minus 3 upon x minus 2. Find the gradient of the find the gradient at the point on the curve where x is equal to -4. So the first thing you need to do is you need to find dy dx. So you can find dy dx and then you'll be substituting either or that value in there. So very important, you are going to use the quotient rule. So you take the denominator x minus 2 times the derivative of the numerator. Now the derivative of the numerator 2x minus 3 is just 2 minus the numerator times the derivative of the denominator, and that is just going to be 1. Okay, derivative of x minus 2. All of this you are going to put over the denominator all squared. So the calculus is done. It's just a matter of us cleaning it up here. So you're going to have 2x minus 4. Okay, and then here you're going to have minus 2x, and of course you must be very careful here as you're multiplying out a negative with a negative. There is going to be a change in sign. Okay, so that implies that we have 2x negative 1 times -3, that is going to be a positive 3. Of course, that 1 into that is just going to be 1. Then you have x minus 2 all squared. Do not expand the denominator, okay, because we're going to be substituting the value of x in there for x. So on top we can actually clear up. Then you're going to have -1 remaining because the 2x is cancel. -4 plus 3 is -1. Everything over x minus 2. So what do we have? We have the derivative function now. Now we need to find what would be the gradient at the point where x is equal to 4, or are they saying -4 rather. Okay, so we're going to substitute everywhere where you have an x value into this function. You're going to substitute -4. So that's going to be 1 all over in brackets -4 take away 2 all squared. Okay, of course that was negative. The answer will be -1. -6 all squared is 36, and that is the gradient. Can give it as a decimal, but that should do. That takes us to the second question, or the second, yeah, and we're starting right off with compound angles, and hopefully by now you're very aware of compound angles. So of course you can look at your formula sheet. Well, you have something like a sine of A plus B. Okay, these auxiliary angles is sine A cos B. Okay, plus the sign remains the same. Cos A, sine A cos B, and then you have sine B now, sine B cos A. Okay, so this is what I'm going to do for this one over here. So that is going to be sine theta cos of 60 degrees plus, okay, that is going to be sine 60, or okay, have sine of 60 degrees, and then obviously cosine theta. All right, then this is not actually done. There is still something that must happen, and this is multiplied by sec theta. Now sec theta is nothing but sec theta is nothing but 1 over cos theta. Always remember that. Okay, so this is basically the same as multiplying this whole business by 1 over cos theta. And in turn, this is equal to positive 2. So from our special angles, of course, you can use a calculator, totally up to you. I do expect an AS level learner to be able to do this. We know that is half pi radians or 90 degrees. This one here is 60 degrees or pi over 3. And this one here is pi over 6. This is 1, that is 2, and that is root 3. Okay. Now, we're asking us here, this is cos 60. I'm going to write cos 60 first. And cos 60, if you come here, cos 60 degrees is pi over 3. Okay. In fact, I'm working with radians. Let me just change them to degrees then, because this is in degrees. That is a little bit not so confusing for people, perhaps. So this is 60 degrees, and this is 30 degrees. Now, sine of 60 degrees, and the cosine of 60 degrees is 1 upon 2. So this is sine theta times 1 over 2 plus sine of 60 degrees. Now, sine of 60 degrees is opposite over that. So that is root 3 over 2 times the cosine of theta. And I'm going to divide all of this by 1 over cos theta is equal to 2. I just want to also emphasize that you can find these values, cos 60 degrees and sine of 60 degrees, on the calculator, and you're going to get the same answer. All right, so make sure your calculator is in degree mode, and then obviously you can just go ahead and you can insert and find your answer. So for example, cosine of 60 degrees, okay, that gives you a half, as you can see. Now let's just clean this up a little bit and just rewrite it. So I'm going to put a half in front of the sine theta. This one is fine over cos theta. Then I'm going to multiply everything here by 1 over cos theta is equal to 2. Now, unnecessary step, but the idea is to divide throughout or multiply each term by that. So I'm going to have a half sine theta over cos theta plus root 3 over 2. Then it's cos theta over cos theta, and then obviously this is equal to 2. Now sine over cos is nothing but tan theta plus root 3 over 2 times 1, because this is actually cancelling. It will cancel. This goes into that. It cancel. Okay. And then this is all equal to 2. Now the idea is to isolate tan theta. Okay. So you will be subtracting. So I have a half tan theta is equal to 2 minus root 3 over 2. Just go ahead and keep them in brackets, because I'm going to be multiplying throughout by 2. So multiplying by 2 here and also multiplying by 2. That leaves you tan theta is equal to, of course, you multiply by 2, you have 4 minus root 3, because the 2 cancel on the side. Right, what is it that they are saying? They are saying that the angle is between 0 and 360 degrees. Okay, right. So what is this value if you have to make sure? Is that value negative or positive? I'm going to say 4 minus root 3. So that value is positive. If you change it to a decimal, you will see that it's a positive number. So this ratio is positive, and that implies that when you have your, I can say, cast diagram, I believe you are familiar with the cast diagram. Then you know that in the first quadrant, the cosine or tangent is positive. So tangent is positive in the first quadrant. And then also it's positive here, the tangent. It's also positive in the third quadrant. So there are some angles that we are going to look for. We are going to look for an angle here. Let's say we call it theta, because it happens to be theta. And this is in the first quadrant. And the next one that we are going to calculate, so 0, 90 degrees over there, 180. And the next one, or let's say we work with that first quadrant first. So in the first quadrant here, we are going to have that theta will equals to the inverse tangent of 4 minus root 3. Let's see what that is. Okay, the inverse tan of our answer, because my calculator was still programmed on that. So 66.2 degrees. 66.2 degrees. The next one, the next set of solution comes in the third quadrant. That angle is all the way up 180 plus that theta more. Okay, so in this quadrant it will be 180 plus theta. All right. Now, so in this particular case, then say in the second quadrant, theta will equal to 180 degrees plus 66.2 degrees. Of course, let's just add 180 to it and see what is it. 246.2. That's 246.2 degrees. Okay, in the range from 0 to 360, and we have solved that. All right. So therefore, theta equals 66.2 degrees and 246.2 degrees. Okay, so that is the solution. Right, I tried to go step by step so that you can see how is it that you can calculate those angles. Right, we're coming to question 3. We're dealing with some logs, but it's also in the form of an inequality. Okay, now they are saying we should solve the inequality. So I suggest there's a little bit of conditions that we need to consider. The conditions of logs, let's say log conditions. First of all, in this one over here, x plus 3 should be greater than 0, x should be greater than -3. So if we happens to get an answer as we are solving and the answer is -4, it will not work under this condition. But that's not the only condition that to be considered. There is another one here, which is this one here. So 2x should be greater than 0 and x should be greater than 0 in answers. So it doesn't matter even if this one here, because numbers greater than 0 are -2 and so on and so on. But this one supersedes the whole condition, and this is what we need to be on the lookout for. Whatever we are going to get here is an inequality, which means most probably this becomes quadratic. We might have two solutions, and then we have to consider that if it doesn't conform to this, then obviously it will not be considered as a solution. Right, so let's then write what this means. So this is the natural log of 2x is in the bracket, so all squared using the power law, minus the natural log of x plus 3 is then equal to the natural log of 2 raised to the power 4. Right, we know what this is, so we can actually write this as 4x squared upon x plus 3 less than equal to the natural log of 16. Now it's very important that you take note of the conditions that I have implied here. Okay, and also that you also know your log laws. Now we here in this particular case, we can actually drop these natural logs and just equate the numbers together. So 4x squared over x plus 3 is less than equal to, I'm going to put that 16 over 1. Now you should not do not cross multiply inequalities. Right, it's not a very good idea. It will definitely spoil your answers. So what we're going to do here, we're just going to make the denominators the same, the LCM the same. So that means I'm going to take x plus 3, that one there remains 4x squared, and here I'm going to have x plus 3, which then implies that this 16 have to multiply by x plus 3. Once we're at this scenario, we can actually drop them, and then we have 4x squared is less than equal to 16, that is x plus 3. Now we can multiply out and see, right, that quadratic becomes. So it's going to be 4x squared, Well, if you multiply, this is going to be, of course, let me just write it out, 16x plus 48, which eventually gives you 4x squared minus 16x minus 48 less than equal to 0. What you can do is you can maybe simplify it by dividing throughout by 4. And when you divide by 4, just to simplify it much easier, we have x squared minus 4x minus 12 less than equal to 0. Now, what is it that we know? We know this is a inequality that they are saying is less than 0. So it's going to open up like so, because the value of a is greater than 0, a being this one over here. And this is the x-axis. So what we are looking for are values below, because the whole function is less than 0 or equal to 0. The whole function is negative. Where is that function negative? It's negative below the x-axis. So we can find what we call our critical values, which in this case I have labeled A and B. And once we have that, I'm going to let this equation, or let this inequality, becomes an equation in order for me to find those critical values. This is a very straightforward quadratic equation that should factorize. You have x over here, x over there, you have a negative, so one bracket is positive. What is negative? And let's see, the numbers are negative 6, I believe, and maybe positive 2. Okay, so x is equal to negative 2 or x is equal to 6. So essentially what this is implying, because it's going to be in this form, okay, it's below, this is what it's implying. But what we need to do is we need to refer to our conditions before we can come up with our final answer. So let's refer to the conditions that I did right in the beginning. We know, if I have to scroll back, we know that x should be greater than 2. This one is redundant. It doesn't really mean anything because it will not work. It will not work on the other one, okay? The other one, if you had to put a negative value. Right. So what is the value that I'm talking about? So the reason, and I hope you get me right, if you take negative 2 of course is greater than negative 3. It will work if you were to put negative 2 in here. Okay, so when you put negative 2 in here, it will work, right? You still get a natural log of 1, which is, you can calculate it, but it won't work when it's here, rendering the whole thing invalid, okay, undefined. So we have to consider x greater than 0. So our condition was that x values must be greater than 0, not equal to. So therefore our answer will be less than equal to 6, but it must be greater than 0, and that is very important that you understand that concept. So you definitely still have to come to that conclusion and do not just assume, yeah, my work is done and I've done what I could. No. Right, that takes us to question 4. We are supposed to differentiate. Now, we have a 3e raised to the x, of course, minus 7, all raised to the power 5, and 3e raised to the 2x, rather. So we can use the chain rule, where you can say y equals to maybe u to the power 5, then my u equals to 3e to the 2x minus 7, all the stuff that is in the bracket. So what does the chain rule say? The chain rule say dy dx is equal to dy du times du dx. So if I look at this one over here, dy du becomes 5u to the power 4. And this one here, du dx, is going to be, now it's very important that you do not get this wrong. Yeah, it's that 2 comes here, then it's e raised to the 2x, and that's what it is. The derivative of negative 7 is 0, which is 6e to the 2x. Now we're going to find dy dx. So therefore dy dx is dy du, which in this case was 5 u to the power 4 times 6e to the 2x. But we know what u is, so we have to put our u back. So it is 5 in bracket. What was our u? Our u, remember, our u, we wrote it over here. It's 3e to the 2x minus 7. 3e to the 2x minus 7 times 6e to the 2x. Just clean it up. 5 times 6, well, that gives you 30e to the 2x, and in bracket 3e to the 2x minus 7. And of course, this has to come, there must be a power of 4 that we nearly forgot, okay? Right, so that is the derivative of that. We have now differentiated that with respect to x. Right, now here they say find the integral of that. Now I just want you to note the similarities. Now, if you have a derivative function and you integrate, that takes you back to the function. So suppose this was a 60, then the derivative would have been 3e to the 2x minus 7 all to the power 5. It will still be that, but however, there's a little something that is slightly different. In the place of where we have this 60 here, take note that 2 times 30 will give you that 60. I'm just going to put this in square brackets. It is indefinite integrals anyway. Then we still write the stuff as it is. So maybe I can play around with the colors. Right, so let's say it's still 2 times, and then this is going to be what? 2 times 30 e to the 2x, and then you have 3e to the 2x minus 7 raised to the power 4 dx. If we integrate the red part with respect to x, the red part, we should get y. We should get our original function, which is the one on top. Okay, that is what we are supposed to get. If you integrate this, you're supposed to get that. So, sitting with that knowledge, then this is what I'm going to do. I'm going to pull out that 2 in front of the integral, this 2 in black. So I'm going to have 2 integrated with 30e to the 2x, and that's 3e to the 2x minus 7 to the 4th, and we integrate with respect to x. But we do know what this is. This is simply, maybe I can just use square brackets. This is simply the original one that we had. And what was the original one? It's this one over here. That is 3e raised to the power x. Let's see if I can take a snapshot of it and bring it down. So that is what we have over here. So that, okay, that is the value. That is what we know. And then we're obviously going to say, if you close this nicely now, you're going to say, okay, then plus the constant of integration. At the end of the day, let me just rewrite it nicely. It's 2 open bracket 3e to the 2x minus 7 to the power 5 plus c. Okay, that's it. And it's 2 marks. There's not a lot that you needed to do, but I just wanted to show you that. All right. Right, that brings me to question 5. And question 5 says the polynomial f of x is defined by f of x equals to 4x cubed plus 16x squared plus 9x minus 15. Now, I would suggest that you are using long division in case you are not 100% familiar with the synthetic division, because when you have take 2x minus 1 equals to 0, 2x is equal to 1, then x is equal to 1 over 2. It means you will have to halve again if you use synthetic division, but you can use long division and you can see what you end up with. Okay, but if you were to do the remainder theorem and you put in a half in here into the function, everywhere you have an x, right, you'll end up with that remainder. That's practically the remainder theorem. So when you have that, you will see that if you punch that into your calculator, okay, then you have got 4 in brackets. It is 1 over 2, and then it is cubed, okay, plus 16, 1 over 2, oopsie, squared, plus 9, 1 over 2, and then minus 15. You'll see that you'll get a remainder of negative 6. So that gives you negative 6. All right, but let's use synthetic division. That means we are going to take this one over here, and we are going to say 1 over 2, and then perhaps I'm not just do that, maybe up to there, so it's not so far. Now we know what the remainder would be, so it's not a big problem. All right, so let me write the coefficients: the 4 over here, the 16 which is positive, the 9 which is positive, and the negative 15. So we're going to bring this one down. A half of 4 is 2. Adding that gives you 18. A half of 18 is 9. Adding that gives you 18. A half of 18 is 9. If you add this, you get negative 6, which is what our remainder is. However, since you are dividing by 1 over 2, you have to divide this 4x squared plus 18x plus 18. You need to divide it by 2. Okay, that's what you need to do. You need to divide that answer by 2, otherwise it will not be the same. That is why I said you rather do the long division if this concept is a bit difficult to you. All right, I have done this also in my previous videos. Okay, so half of 4x squared is 2x squared, and half of 18x is 9x, half of 18 is 9. All right, so, and then we also know that our remainder is negative 6. Right, so this is our quotient that we were supposed to find. Right. Now, why is this part important? And it's linked with integration, and it's actually very straightforward. Now that you know, if you divide f of x by this, we know that we are getting 2x squared plus 9x plus 9, but we remain with 6, and we put it all over that 2x minus 1. That's what we do. All right, and we're going to integrate this with respect to x. So these two statements are actually exactly the same. Right, let's see if I can just make this into two integrals. So this is 2x squared plus 9x plus 9. Let's say we have this one minus, and I'm going to pull out that 6, and then I'm going to have 1 all over 2x minus 1, also integrated with respect to that. Now, let me just bring in maybe a quick rule that you might have forgotten. And the rule is having to do with this one. If you were to integrate, just want to see because I might not have enough space. If you were to integrate, I'm going to write it here. If you were to integrate 1 over ax plus b with respect to that, then the integral of that, okay, for any natural function is the derivative of the denominator. Okay, so you take the derivative of denominator, or first you can say it's 1 over a. Always important that you do understand it. And then it becomes the natural log of ax plus b. And then obviously plus the constant of integration. Now I'm going to slap here absolute value sign because this has to be a positive value. Okay, in some cases we can also say ax plus b should be greater than 0. Right, so this is what I'm going to apply in the second one. That is why I was separating them. On this one, I'm going to apply that rule. Here, you can integrate like normal. That is 2x cubed divided by the new power. 9x squared divided by the new power plus 9x. Okay, minus 6 times 1 over a, which is 1 over 2, and then the natural log of 2x minus 1. That is what I'm going to have over here, plus the constant of integration. The calculus is done. It's just a matter of me cleaning this up a bit. So this is 2x cubed over 3 plus 9x squared over 9 plus 9x, and a half of 6 is minus 3 natural log of 2x minus 1 plus the constant of integration. And this is how you integrate that indefinite integral over there. Okay, so quite a number of steps, and then please, you must make sure that you do not skip any one of them. Right, now there is a similarity here at part C with what we have over there. So let's just quickly say, they are saying, and I'm going to do this part, we are supposed to factorize that. Now, there was a remainder left. So if there is no remainder left, then it means x plus 2x minus 1, I believe. You just see, what was that factor? When you divided it, it was all the way back here, it was 2x minus 1. Now, if you are adding 6, that means there's no remainder. So 2x minus 1 is now a factor. So 2x minus 1 is now completely a factor, leaving no remainder. And what is the other one? The other one is what we calculated. It is this 2x squared plus 9x plus 9. So the 2x squared plus 9x plus 9. These are all factors now. Okay. Now, they want us to make it an equation and solve it. So let's say equals to 0. Right. So on this side, we have 2x minus 1. And hopefully, you can find time and factorize this, realizing that it will become 2x plus 3. And then the other one will become x plus 3. Okay. At this stage, expect an AS learner to be able to factorize that. Okay, so I'm writing the roots as it is because every bracket will equal to 0. So again, this is x equals to negative 3 over 2, or x is equal to negative 3. Those would be the roots, the solutions, okay? But that's not what we're looking for. Right, there's a similarity here. There's a similarity here between, I'm going to take this off and put this color so you can see, between f of x and f cosec of 2 theta. All right, so if that is the case, if we have a condition where they say that x is equal to cosec 2 theta, and I hope that you know which is the same as 1 over sine 2 theta. So each one of these roots will have to equal to that. Hopefully that makes sense to you now. No? So x, which is now 1 over sine 2 theta, equals to a half, or 1 over sine 2 theta equals negative 3 over 2, or 1 over sine 2 theta, which is just the same as cosec, equals to negative 3. Right. I want that sine 2 theta on top, so I'm going to take the reciprocal of both sides. So sine 2 theta equals to 2, and this cannot work because you know that the sine graph oscillates between 1 and negative 1. What about this one? Let's change here. So this one becomes sine 2 theta is going to be negative 2 over 3. Good. What about the other one? The other one, sine 2 theta is going to be negative 1 over 3. So these are the only two that we will be considering. Now, here's the thing about all of this now. You can see that for both, what is our original domain? Our original domain is between 0 and 135. So I'm just going to bring that back. Let me take a snapshot of that domain. So this is our domain, our original domain, but this is now a compound, so we're going to have a new domain. Okay, so we have now two. Let's just write it down. So we have 2 theta, so we're going to multiply each of that by 2, and then if you so obviously say 135 times 2 is 270, 135 times 2 is 270. Good, so that's 270 degrees, and 0 times that is just going to be 0. What does that mean? So if we were now to consider both scenarios for even the blue, if you do the cast diagram, then the angle we are going to look for has to be in the third quadrant. Okay, so you have got 0, you have got 90 degrees, 180. So this is the angle we're looking for. How do you find that angle? Well, you say 180 plus theta. So this is now for both of them will be like that. Okay, because it's also the same case. So let's say we take the blue one. Okay, let's say we find the basic angle of the blue one. The basic angle of the blue one, that will be sine, inverse sine of 2 over 3. And when you find the basic angle is the acute basic angle, you are not going to put your you're not going to put, the positive, the negative sign there. This is degrees, calculated in degrees mode. Inverse sine of 2 over 3. What is that angle? It's 41.81. So I'm just going to write 41.8 degrees. And what is the other basic angle going to be for this one here over the red one? It's also going to go in that quadrant. Okay, it's within our new domain because it's 0918270, so it's within our new domain. So this one, this basic angle on this one will be the inverse sine of 1 over 3. Do not put, okay, do not put that value there. I'm doing them simultaneously. Hopefully you're not getting confused. That is 1 upon 3. And we get an angle of 19.5. So let's say 19, we keep it 19.5, okay? I'm just going to write here 19.5 degrees. Right, so let's say we are now looking at this one over here. What is that answer going to be? It's also in the third quadrant. We know that it is 2 theta is equal to, it's in the third quadrant, so it's 180 degrees plus 41.8 degrees. Okay, and that is going to be an answer that you will be taking, and then you will be dividing that answer by 2. So let's see, we have 180 plus 41.8. We divide that answer by 2, 110.9 degrees. So 110.9, which is within our original domain. So that is a solution. Now, if I consider the other one in red, the one that I also considered, this one, with the reference angle of 19.5, which also will be in the third quadrant, then 2 theta is going to be 180 degrees plus 19.5 degrees. And that answer, we are also going to divide that answer by 2. So theta will be, let's bring the calculator, that's 180 plus 19.5. Hit enter, divide that answer by 2. Okay, is it within the domain? 99.8. So it's 99.8. It is within our original domain of 0 235. So we're all good to go. Therefore, this is 99.8 or 99.7. Let me just see if I did not. It was a 99. So it's 180 plus 19.5. What do I get? I get this, dividing that answer by 2, 99.8. 99.8. Give or take. 99.8. Okay. So my two solutions, therefore, my two solutions would be that theta is equal to 99.8 and 110.9 degrees. There we go. So those are the solutions. And yeah, so it is really interesting. And how this question is set up, we have some integration part on it and so on. Quite interesting question, and make sure that you show all your working as you go along. Right, let's look at question 6. Show that the exact value of that integral is equal to all of that. Now, there are a lot of things that I expect you to know, right? So I'm looking at a few of them. First of all, I'm going to rewrite, so that's from 0 to pi over 3, and I have cos square x plus 1 over cos, and here's the thing that you need to know. 1 over cos x is the same as sec x. Really important that you know. So this is the same then as sec square x dx. So I'm doing the left-hand side. Okay. Then I'll have to know also from my compound angle. Okay. From my compound angle, and hopefully it's going to fit over here. I know that this I can write, because you cannot really integrate that. Okay. So, but what I know is from cos 2x, and you will find this in your formula sheet. Okay. I have 2 cos square x minus 1. That's identical to that. It's one of those three identities that the double angle of cosine of 2x is going to give you. The reason why I'm doing that is because I want to make cos square x the subject of the formula. When I do that over here, right, I'm going to have cos plus 1 is going to be equal to 2 cos square x. But I'm looking for cos square x, so I must divide all of that by 2, okay? Or dividing by 2, I would just say that cos square x is equal to 1/2, and then it's going to be 1 plus cos 2x. Right, now all of this on the side is now going to replace. It's identical to, I'm not yet integrating, I'm just giving the identical, way of writing cos square x. Okay, so this now implies I'm going to have to integrate this cos square x. Now it's written as 1/2 1 plus cos 2x, all right? And then one more thing that I need to bring in, and that is, and I hope that you are familiar with this identity, and this identity that you should be familiar with is that sec square x, if you integrate it with respect to x, is just tan x plus c. So when I integrate that, sec square x, I know what is it that I am going to get. Right. Is there something more? Right. Another rule that I expect you to know, another one that I expect you to know before you integrate, is when you integrate the cosine of ax plus b type with respect to x, then that is going to be 1 over a times the sine of ax plus b plus the constant of integration. Very important that you take note of that you know what it will become. All right, now I can actually multiply out whatever this is so I don't sit with a problem. So I'm just going to keep it as it is and multiply that half. Okay, that half over, that's 1 over 2 plus 1 over 2 cos of 2x plus sec square x dx. I can actually now start with my integration. If you were to integrate, you will be getting 1 over 2x plus 1 over 2 times 1 over a, which is 1 over 2, sine 2x. Please refer there. All right, and what do we know? We know that sec square x is just 10x. And we're going to do this from 0 to pi over 3. Calculator should be in radian mode if you were to find that exact value. Let's clean it up before we put in our limits. And if you do, you get a half of x, okay, plus 1/4 of sine 2x plus 10x, and we are going to integrate from, or we're going to substitute those limits in. Now let's substitute the limits in. So I have 1 over 2 of, the upper limit is pi over 3, plus 1 over 4. Now, let's see if I have space to work with. Okay, I have still enough space to work with. Okay. Then this is going to be sine 2 times pi over 3 plus tangent of pi over 3. All of this, that is the upper limit. We're going to now take the lower limit. And if I run out of space, I'll just continue next slide, which is a half of 0, okay, everywhere I have x, plus 1/4, you must write it, sine of 2 times 0, 2 times 0. I think I must just write 0, just not to make things look so complicated, because 2 times 0 is that, plus, I'm running out of space, and then I have 10 of 0. Now, I don't have to concern myself too much with that, because I know that that side of the limit is just going to be 0. Now, I'm going to write down what I have. I have 1 over 2 times pi over 3 plus 1 over 4. Now, grab your calculator, please. Make sure it's in radian mode, because you're dealing with angles. So I'm just going to change my mode to radians. So I have 1 over 4. This is the part that I am interested in doing on the calculator. So I'm doing this part over here and see what value is it that I'm getting, okay? So the calculator back, look it up a bit. So I have sine of 2 pi over 3. That's what that yellow part means. That's root 3 over 2, okay? So times root 3 over 2. Plus, I'm going to use my calculator again, and I'm going to calculate this part here. This is on the calculator. Although I might know what it is from special angles, but I want to show you step by step, okay? So that's 10 of pi over 3, okay? What do we get? We get root 3. So that is root 3, that plus root 3. Minus what? Minus 0. 0 there, 0 there, 0 there. So let's see. What is it that we have? We have pi over 6 if we multiply these two over here. That gives me pi over 6 plus, if you take these two, you get root 3 over 8 plus root 3. That is like over 1, right? Then just take this and put them over the same denominator. Pi over 6 plus putting this over the same denominator, that is root, oh my goodness, that is root 3. So what you need to do is you need to multiply here by 8 and also multiply on top by 8, which will be plus 8 root 3. Nearly there. Okay, just to add those numerators. So it's pi over 6 plus root 3 plus 8. There's a 1 here. That is going to be 9 root 3 over 8. And I believe this is most probably what we were supposed to prove. But we'll see. We'll go get it and see if it is exactly the same. All right, so let's scroll back and see whether we have indeed proved the correct thing. So I'm going to take a snapshot of it. I'm going to take this over here and see if it is what we were proving. Okay, let's see. We got liftoff. It's exactly the same. We have proven that. Okay. Right, quite a lot that you had to unpack there. Also a lot that you had to remember. Okay, and also a lot that you have to refer to your formula sheet. Okay, good. Now, let's see if we can do B. Now, B is really interesting. It says the diagram shows the curve for y equals to cos x plus 1 over cos x, okay? And it's between 0 and pi over 3 radians. The region is bounded by the curve, and the line x equals to 0, that's the y-axis, x equals to pi over 3, and y equals to 0, that's the x-axis. What are we supposed to find? The exact volume. I'm going to stop at the word volume there. Then we know that volume is pi integrated from a to b of your function squared with respect to x. This is how you find volume. Right, so this part here is my y. You can see my y. Let's bring this color, is a little bit bad. So this y here represents this one. Right, so let's use it. And my a and b, I think you know what it is. So to find the volume, then you're going to integrate from 0 to pi over 3 of the function cos x plus 1 over cos x squared dx. Let's do that first and see where it brings me. Okay, now this is the same as cos x plus 1 over cos x times cos x plus 1 over cos x dx. Now we're going to multiply and distribute, okay? So pi, this v equals to pi from 0 to pi over 3. And we have cos square x, that is if you multiply this one with this one, okay? And then if you multiply this one with this one, you'll have cos x over cos x. And then if you multiply this one with this one, you get the same. It's cos x over cos x. And lately, when you multiply those two together, you'll have 1, because this times that is going to be plus 1 over cos square x with respect to x. We're still busy with the algebra. Can you believe it? Right, let's clean up and see what is it that we are getting. The volume is equal to pi between 0 and pi over 3. And then I'm going to write the red part first. Cos square x plus 1 over cos square x plus 2. And where is that 2 coming from? This is 1. Remember, this here is just going to be 1. That is also just going to be 1. So 1 plus 1 is 2. Okay. And then we're going to close that off with the x. This in red here, we have done it. We have calculated its area. Is this one. This was the area of that one. Can you see that? The only thing that is not there is the pi. Right. So let's see. This represents that the only thing that was not there is the volume. So this is only the volume that is missing, because we got that. Plus the integral of 2 dx between 0 and pi over 3. But then it should also get its own volume. Its own pi. So this part here, I'm actually done. I can actually do this here. I can do that one there. That is pi squared over 6, multiplying everything by pi, plus 9 pi over 8 root 3. That part is done. Plus, now we come to this one. So if you integrate this, you're going to get pi outside, and you're going to get 2x, and it's going from 0 to pi over 3. So it's only that little part that we need to finish off, okay? So if you do this, you're going to have pi, and then you have 2x. Now x is the upper limit, which is pi over 3 minus pi times 2 times 0. Okay, if you do this other part, this one we're just going to write it as it is. It's pi over 6 squared plus 9 pi over 8 root 3. Once you do this part, it becomes 0. And if you do this, you have got 2 over 3 pi. So I'm just going to write it under here, see if I have space. This part becomes 2 over 3 pi squared. Let's bring it together with its sister being pi squared over 6. All right, and then the other ones still remain 9 pi over 8 root 3. No, it's a little bit tricky, right? You might not have enough space to work with. So let me just insert and append a page maybe, so we don't have to work like that. All right, let's just rewrite what I have in red there. I have 9 pi over 8 root 3 plus pi square over 6 plus 2 pi square over 3. Very good. So this can be removed. So we're looking for exact volume. We are there. It's just the other two where the like terms are. Okay, we are there. We are there. We are there. And if you now take this one over here, okay, let's just save. What do we have? All right, this one stays 9. Maybe I put the root 3 here over 8, and I put a pi in the middle. If you add 1 over 6 plus 2 over 3, 1 over 6 plus 2 over 3 will give you 5 over 6 pi square units cubed. That is the volume, the exact volume. So a lot to do, a lot to unpack. You could have done it in a different way and still arrive. You have to arrive at that answer. So it's quite a lot. You needed to be able to see also the connection between cos square x plus 1 over cos square x, which you have done. So no need to repeat. But of course, you could also have said, no, you know what? I could have been here, start again, and then integrate, but you still have to get to the same answer. No decimal values allowed. We are told that you are supposed to find the exact volume, and it's in the question, right? It's in the question. If you go, I highlighted it there, right? There we go. There we go. There's also something really interesting if you were to look at that function, just if you had to visualize it, okay, let me bring that back. Not that you have to do it, but I'm just feeling that maybe I should explain it a little bit more because I have space here. If you had that function and if you had to take now the volume, right, and you rotate that function, so maybe in red, oopsie daisy, and if I was to continue with this, perhaps also it does look like it's something that goes a little bit like this and a little bit like this, okay? So it would have been something that rotates, some shape like this. Okay. And it rotates about what? It rotates about the x-axis. That's the volume that we are talking about. As you are spinning that, as you are rotating that about the x-axis, as you are rotating that rotated completely about the x-axis. So that is the volume that we are calculating, basically. Hope that is clear. Right, let's go into question 7. Now, this paper has got, I believe, 9 questions. We'll see. We are getting close to the end. Right, the diagram shows the curve with parametric equations. As you can see, x is equal to 3t minus 6e to the negative 2t. This was last year's question paper. And then y equals to 4t squared e to the negative t for the values of t between 0 and 2. A point P on the curve, at point P on the curve, the y coordinate is 1 over 4. The only thing that you need to do there is you take that y equation and you let it equal to 1 over 4. And we should arrive at something like that. So there are many ways you can do that. Okay. Let's have t square alone here. So I can take the square root. I've got 1 over 4 e to the, to the negative t. But now if I divide that by 4, it's the same as multiplying by 1 over 4, right? So if I divide by 4, just want to remove this. Well, let me say I divide that by 4 as well, right? So basically this is 1 over 16 e to the negative t. Then I do not like that e to the negative t, right? So I'm going to write it as 1 over, just want to spare in some, let's just continue here. So we're going to write it as 1 over 16, oops, 1 over 16 e to the t. So 1 over 16 e to the t. 1. Now that negative is not there. Right, how am I going to get rid of that t, that square there? I'm going to get rid of that by simply taking the square root or by multiplying all of this by a power of a half. The square root of 1 over 16, I know it's 1 over 4. And e, now multiply that, that's going to be e raised to the 1/2 t. There's a reason why I wanted that, so that you can see that this is exactly the same as that. Okay. Then they say use the iterator formula with t sub 0, starting obviously there, to find the value of t at p. Okay, right, let's calculate the time, starting obviously from t sub 0. So just write it down, what I have. So I have t sub 0 is equal to 0.4, and then I'll have this, and so on, and I'll have that, and we'll see how far we go, okay? Find the iterations. Right, nothing to worry about with the equation. So we just punch it in on our calculator. This is 1 over 4 and then it's going to be shift using this one over here. That is going to be 1/2. Right, now what is our okay, my goodness, before you do anything you must press 0.4 equal to. Now you can press your function. Okay, so function is 1/4, and we just look at nicely where is this, is here. Then it's raised to 1/2 answer. Press equal to. This is going to be my first or my second iteration. I'll just capture that screen. I'm just going to write it on that side. I know for each one of them I must give the answers to 4 significant figures. And then if I want the second one, I just press equal to. I'll take that, capture the screen, paste. So this is the second one. Then they say 3 significant figures. I don't see it yet, so I'll probably have to go to do a third one. Press equal to. Then if I capture that, this is the third one. This is the third one. Okay. I don't see it again to three decimal places or significant figures. Press equal to. I think I'm starting to see it converges upon a number now. I think I can do one more just to make sure, because I can see 0.289, 0.289, and that is what it is to 3 significant figures. Okay, maybe I'll just do another one and so on. Yeah, nothing much is happening, so we are on the right path as far as that iteration is concerned. So I think I did enough iteration to justify whatever my conclusion will be. So let me just write down my T1 just so that I can do that to 4 significant figures, and that is going to be 0.305 554. The second one is 0.2912. Then the third one is 0.2892. You wanted 4 significant figures there. And then the fourth one is 0.2889. Then the last one that I have over there is 0.2889. Right. So what is it going to be to 3 decimal places? I mean, 3 significant figures is here. It's here. Even there. I can therefore conclude. I can say T is equal to 0.289. That's what I wanted. Okay, that's what I wanted there. Right, so this is my solution. It converges to that. Very interesting. You didn't have to do 5 iterations. By 4 up to there, you already can see what your answer will be. But it's important that you do write them to that 4 significant figures or more, so that you can later on write your correct answer to 3 significant figures as indicated. Right, so we have that. Now they are saying, by using your answer in B, that's 0.289, I believe. So they are saying using the answer in B, what is our answer? Our answer in B, T is equal to 0.289. Find the gradient of the curve, giving your answer correct to 2 significant figures. Let's go find those equations there, because this is a parametric equation. So I'm just going to take those 2 values and I'm going to bring it, because I'm going to use the chain rule, so to speak, right? Okay, right. So let me just paste it over here. Now, what does the chain rule say? The chain rule, of course, by now should not have a problem with it. We're going to do dy dx is going to be equal to dy dt this side, all right? Which I'm going to write here, dy dt times, well, it should be dt dx. That's what we are supposed to get, times dt dx. It's as if those t's are cancelling each other. So that is what we need to work with. Right, taking note that this is x equals to, so first I will do dx dt and then I will be swapping that around. Now I want to do dy dt because I'm realizing there is there's a product rule that comes in play there. If you look at here, you've got two functions that are multiplied together. So for me to differentiate, I will be using that product rule. So I'm just going to start off with that one, and I will do the other one, okay, separately. So y equals to 4t squared e to the minus t. Product rule. What does the product rule say? dy dt. The product rule says keep the first one, 4t squared, plus the derivative of this one, which is negative e to the minus t, plus keep the second, e to the minus t, times the derivative of 4t, which is 8t, 4t squared. Okay, let's clean it up. dy dt, then dy dt is equal to negative 4t squared. Is it supposed to let's write it separately. You see, negative 4t square e. That's the thing. Why did I put a plus here? 4t squared. There should not be a plus. Should be multiplying that, no? Should be multiplying that really. It's this. Keep the first, the derivative of the second, plus the second derivative of the first. Good. So it's negative 4t squared e to the minus t. This negative is the one that is there. Plus 8t e to the minus t. That is the dy dt. Good. Let's find the other one. I'm going to write it in a different color here. It's given to me as x equals to 3t. I'm trying to save space, minus 2t. So I'm going to do dx dt because that's how it's given for now. And if you do the derivative of 3t, it's just going to be 3 minus 6, then it's times negative 2 to e to the minus 2t. Let's just clean it up. It's 3 plus 12e to the minus 2t. So this is dx dt, but we are looking for dt dx. So dt dx means you'll just swap this around. So it's going to be 1 over 3 plus 12e to the minus 2t, minus 2t. Right, therefore, dy dx is going to be all of this, which is negative 4t squared e to the minus t, plus 8t e to the minus t, all over, okay, because we're multiplying them, 3 plus 12e to the minus 2t. That is dy dx, right? Just to make sure that I can bridge it nicely so you don't get confused. Right, were we supposed to prove this or did I have to do it for myself? Let me see. We had to find it. Okay, so there's no auto marks in there. So if you make a mistake, then your answer, subsequent answer, will definitely not be okay. So what is it that they're asking us? They said we must find the gradient at t equals 0.289. 0.289. What will that give us? Right, I'm not going to rewrite all of that. I'm just going to work with the calculator to see what is going to be the gradient. So let's grab our calculator. So I'm going to press 0.289 and I'm going to say equal to. That is the answer that I want, okay? Because I don't want to press it every time. So I'm going to substitute in this one. What do I get? I have negative 4 answer squared e, or should I write times? Okay, let's just say e to the negative answer, okay, plus 8 answer, okay, what happened to calculate disappeared, plus 8 answer, right, e, whoopsie daisy, e here to the negative answer. Now I'm starting here, 3 plus 12 e negative 2 answer, hit equal to, oh, it's a mouthful, that's the correct answer. Right, you don't have the liberty of using such a calculator or copying and pasting, so you must make sure that everything works out. So what did they say? We should give this answer correct to 2 significant figures. So we're going to give this answer correct to 2 significant figures. So that means it's 0.15. 0.15. Right. That was a whopping 5 marks, and you had to use the chain rule and so on. I hope you know how to differentiate parametric equations. All right, I did quite a number of these on my YouTube channel. Right, here we go. We have got question 8. Again, I think there's still more. They say sketch the graph of y equals to 3 e to the x. Now this the standard graph y equals to e to the x will go up like that. So let's see. This graph is going to go. There you go. It's actually very nice. So this is the graph of y equals to 3e to the x. What is the equation of the y-axis? This happened when x is equal to 0. So when x equals to 0, then y equals to 3e to the 0, which is just 3. So this one passes at 3, this point here. Okay, I'm just going to put it here. That is 3. Basically, I'm done with that one. It forms an asymptote, remember. It gets closer and closer, but it will never pass. The other one, I'm going to do that in blue. This other one is y equals to 1 over e. This graph will come down. It will have that decaying issue, comes down like so. Maybe I should start over with that one. Because it comes all the way from wherever it comes from. Also formed an asymptote rather. So this is the graph y equals to e to the minus x. And if you look at that graph, 1 over e to the x, right? If you look at this graph, when x equals to 0, when x equals to 0, then y equals to e to the negative 0, which is 1. So this graph is cutting there. That's it. That's what they wanted, right? Now you can clearly see that this graph is going to intersect, and at the point where they intersect, the two functions will be equal. This 3e to the x will equal this one. That is what they probably will be asking us in the next question. Calculate the exact coordinate at the point where the two graphs intersect. The exact x coordinate. Now you can also see from my graph it has to be a negative value. Alright, so we can actually find that. It's not a big deal. Okay, just use algebra. So we take the two functions, right? One graph was y equals to e to the minus x. The other graph was y equals to, what was that graph? 3e to the x. So therefore, let's equate. If both of them equals to y equals to, then I believe that 3e to the x is equal to e to the minus x. What is it that I'm going to do? Well, I'm going to divide this side here by e to the x. I'm also going to divide this side here by e to the x. This is going to leave me with 3. Now, what do we get over here? So let's bring a little bit of side work. you have e to the minus x divided by e to the x. The rules are when you divide and the bases are the same, you subtract the indices. So this is what you get. So on this side, you're going to get e to the minus 2x. Now, the next thing is to take the natural log of both sides, the natural log of e to the minus 2x. Then I use the power law. Power law, okay? Let me rather write this thing on the left. So it's negative 2x natural log of e is equal to the natural log of 3. This naturally becomes only 2x, and then it's natural log of 3. Hopefully you do understand that this natural log of e, again, the natural log of e is the same as log base e of e, which is 1. It's a lot of things that you really need to take note of so you do not make mistakes with them, right? Okay, so these are just side words. So at this day, I can actually isolate x by dividing throughout by negative 2 or multiplying by negative 1 over 2. It is the same thing. Leaving it like this is an exact form, and that's what they requested. There we go. So this many ways, but this is one of them. Okay. Of course, you might have got a different scenario, but still the same numerical value. If you were dividing throughout by e to the x, negative x, you will still get the same thing, just slightly written differently, but the value of it will be exactly the same. All right, so nothing to fear there. Right, that brings us to question 9. Question 9, acute angles measured in radians. There are 10 questions, or 11 questions, or is there more? Let's see. Right, so we have a few to go. So let's finish and move along. I am now busy with question 9. It is given that x is trigonometry is measured in radians. Calculator must therefore be set in radian mode. Okay. Also, another thing worth noting, and hopefully you should notice, is that sec square x is identical to, remember from sine square x plus cos square x is identical to 1. If you divide throughout by cos square x, so if you divide here by cos square x, cos square x, cos square x, what you'll end up getting is this becomes tan square x plus 1, and this is sec square x because it's 1 over cos. Now what I wanted to say here is, you see where you have sec square x, I'm going to replace that whole sec square x by this value here when I do that. So at the end of the day, this is 2 in bracket, it's tan square x plus 1 minus 3 tan x minus 22. It's like a hidden quadratic equation. Okay, let's carry over. It's 2 tan square x plus 2 minus 3 tan x minus 22 is equal to 0. It's 2 tan square x minus 3 tan x minus 20, that is 2 minus 22. Okay, this should factorize to 2 tan x, in bracket you'll have tan x minus 4, and then you have got plus 5, and then you're going to have tan x minus 4. Okay. You should be able to factorize those things. Okay, now let's see, what do we get? We have, remember, the question doesn't want us to find the value of x, rather it wants us to find tan x, and then they also say tan that x is an acute angle, and x can only be an acute angle if the ratio is positive. That tan x, whatever tan x I get, I must have a positive one. Okay, right, so let's go on. So you have got 2 tan x plus 5 in its own brackets, and then you have tan x minus 4 in its own bracket. So equal, everything should equal to 0. If you do this, you're going to have tan x is equal to negative 5 over 2. So I'm going to reject this because it doesn't conform to the condition. that they gave me, because they said that it should be a positive acute angle, and this is tangent is negative, this ratio is negative, so therefore tan x is equal to 4, which is the required solution. Hope that makes sense. So, right, using your value of tan x, now of course you will have your calculator, and in your calculator, maybe I should go grab it, not the calculator, but let me go grab the double angle for tan A plus B. You can go ahead and do that, of course, in the event that you find it a bit tricky. Let's see, it's all over here, so I'm just going to take a snapshot of it as this. No, it's not that one, it's not that one. That one actually derives from this one over here. That's what I'm looking for. I'm just going to write it next to that so that you can see how do you apply it over here. And also read the question very careful, okay? Just going to write it over here. But you're not going to use A and B now, okay? Your A is X, your B is 3 pi of that. So let's just write it using that format first. So this becomes 10 x plus 3 over 4 pi is going to be 10x, that's a plus, so on top it's going to be plus 10, well, it's 3 over 4 pi, and all of this is 1 minus now, minus tan x times 10 of 3 over 4 pi. But we know what tan x is from our answer before. So from our previous answer, tan x is 4. So this 10x, everywhere you have a 10x, you're going to replace it with a 4. And also, it will be quite interesting for me to know just what is 10 3/4 of pi. And you will see if you use your calculator that it's -1. All right? So 10, okay, it's radian mode. You have 3 over 4 pi. Okay, oopsie. 3 over 4 pi. That's -1. Good. So that means, again, where I have this, I'm going to replace it by this. Does that make sense? Right, so let's go ahead then and do it. So this answer, this is 4 plus -1 over 1 minus 4 times -1. That's what we get, because it says find the exact value, and your calculator should be in radian mode, okay? So on top you're going to have you're going to have 3, and under you're going to have 5, and that is the exact value. Good, let's continue. Question 10. They say the equation of a curve is y equals to natural log of 3x plus 10 minus 2 times the natural log of x. Find the x coordinate of the stationary point. What does that mean? This means that dy dx is equal to 0. So we need to find the derivative. Again, you need to be able to be familiar with how do you find the derivative of a natural log function. So quickly on the rules, if you do d by dx of a natural log function, and this is actually going to be the derivative of that function all over f of x. Please don't forget that. So I can write this as, let me write the equation. It's 3 natural log of 3x plus 10 minus 2 natural log of x. And also, the derivative of the natural log of x is nothing but 1 over x. Something you should know. Right, so dy dx is equal to 3 times the derivative of the stuff inside. What is the derivative of stuff inside? It's just going to be 3 all over, that looks weird, let's say 3 times the derivative of stuff inside, that is 3 all over 3x plus 10, okay, so this multiplies together, minus 2 times the derivative of that is 1 over x. So let's clean it up a bit, okay. I have 9, the numerator here, over 3x plus 10 minus 2 over x. Alright, that's what that gives me. Now what do they tell us? They tell us the stationary point, so dy dx is equal to 0. So I'm just going to, because of the space issue, also where, right, I'm just going to say let this equal to 0 over here. Then you have 9 over 3x plus 10 is equal to 2 over x. And we're going to do a little bit of cross multiplication. I'm just going to do it on the side. So I'm going to have 9x is equal to 2 3x plus 10. Then this is 9x is equal to 6x plus 20. Then 9x minus 6x is equal to 20. So all of this is going to say that x, therefore, because it's 3x, x is 20 over 3. And this is my answer. Okay. Right. So they find the x coordinate of the stationary point. We did locate it. Okay. What do they say? Determine the nature of the stationary point. That means we have to find the second derivative. Okay. What is the first derivative? Let's write down. Dy dx is, I'm going to write it down like this. That's what this means. Minus 2, and that's what that one means. So if I have to do the second derivative, okay, so d square y, this is just notation. Then remember, you're going to have negative 9, keep the same stuff, take away 1, times the derivative of stuff inside, minus negative times negative becomes a positive 2, x to the negative 2. This is the second derivative. Don't waste your time trying to write everything as it is. Determine the nature of the stationary point when the value of x is what? When x is equal to, so when x equals to 20 over, when x is equal to 20 over 3. Let me grab my calculator and see what is it going to be. Okay, that's negative 9, open bracket, 3, I have 20 over 3, plus 10 raised to the power of negative 2, plus 2, I'm now here, now plus, oh my goodness. This is actually not entirely finished. You can see that 3 times that is negative 27, so negative 27, 3x plus 10, negative 2, plus 2x, negative 2. So let's see, what did I do? I'm going to just put a minus 27 in the place of the 9. Okay, minus 27. And then it looks now nicely, just like the other one. Okay, plus 2, the bracket is 20 over 3. And it should also be raised to the negative 2 power. Alright, we get 3 over 200, which is like 0.015. So that is 0.015, okay? 0.015. So, what does that mean? It means if that is the case, if the second derivative is greater than 0, as this case will be, then that is going to be referred to as a minimum point. Minimum. That is the nature of that point now when you are thinking of if you were to look at that graph. Okay, that is it as far as determining the nature of the stationary point is concerned. Very interesting question indeed. That brings me to question 11. Question 11 says we must sketch. We have an absolute value graph, and these things are given in terms of A, nothing to be afraid of. There are quite a few number of things that I would probably want to emphasize on before I'm just going to append the page. So I can just do a little bit of sort of, yeah. We are supposed to sketch this one. So I just want to take a snapshot of that. Okay. And then also, very important, they are saying where A is a positive constant. So A is a positive constant. Right. Let's work with the salient point, which is the vertex. So the salient point, I'm now busy with the absolute value function. Let's take 1 over 4x, the stuff inside there. Let's say it equals to 0. This in turn will tell me that A equals 1 over 4x. Very important. Okay, or 0.25x. Then alone, this also therefore means that x is equal to 4a. Now this is important. Good. What else do I need to know from that? I need to know something else, okay? They are saying A is positive, so where A is a positive constant, right? Then where will this graph, the y-intercept, where will this graph, the absolute value graph, where will it cut the y-axis? It does that at x equals to 0. This happens at x. So therefore, looking at my graph, then I'm going to have the absolute value of negative a, which is a. So I know where the y-intercept is. It's going to take place at a. What else do I need to know? I have my a, y-intercept, and so on. Right. So let's go to the graph. If I have to draw it here like so, and this one is going to be a reflection of that this way. Right. What I said, the vertex here is 4a, and that is a. So this is the graph of y equals to 1 over 4x minus a. That's the absolute value graph, the blue one. Okay. Now I want the straight graph, straight line. I'm going to start with it over here. The y equals to 3 over 4x minus, so let's take that one. Let's consider y equals 3 over 4x minus 1 over 4a, I believe. Where is it? There's that one. Right, what is it that we need to know about this graph? Well, if you want to know where this graph is going to cut the y-axis, the y-intercept happens when x equals to 0. So this is y equals to 3 over 4 of 0 minus 1 over 4a. So it will do it at minus 1 over 4a, which is like we have an idea where that is, okay? It's below. So we know now where that graph will cut, where that graph will cut the y-axis. So if I have to go to my diagram, it's going to be somewhere over here, okay? Like somewhere over there. As much as I want to know where a graph will cut the y-axis, I also will want to know where it will intersect with the x-intercept. The x-intercept, and this happens when y equals to 0. So using this equation, I will say negative 1 over 4a equals to 0. No, that's not a correct equation. That's not all of it. It is not 3 over 4x is equal to 0. That's the equation, because the equation was y equals to 3 over 4x minus 1 over 4a, no? Which is over there. Right, so if we make y 0, that means from here I can have 3 over 4x equals to 1 over 4a. I can actually go ahead and I can drop the 4's, and then if I do that, I have got 3x equals to a, 3x equals to a, then x is equal to 1 over 3a, which is more or less what I know what that is. Right, let's bring in those values. It cuts the x-axis at 1 over 3a, it cuts the y-axis at negative 1 over 4a. So let's say negative 1 over 4a. So my graph, let me draw it first. I have a pretty much good idea where that graph will be. Something like this. Where this point over here, let's say this point over here is negative 1 over 4. And this point over here is 1 over 3a. There we go. And this equation is y equals to 3 over 4x minus, what is that equation? Minus 1 over 4a. That is the straight line. And I actually have sketched it. No problems to ask. It's really interesting. What I'm going to do is I'm going to look at what is the next question. Part B, find the coordinates of A in terms of the point of intersection of two graphs. Now, this is very interesting. You know, if you look at that blue graph, you can see that is the negative leg of it, okay? So it's the negative leg of that blue graph. So I know what it was. It was 1 over 4x. So just looking at the blue part, just this one part. So I'm going to say I'm taking that as a line. So if I look at that, I know that as a line it's 1 over 4x minus a, but I'm looking at a negative part of it, okay? Because it goes down. It's like the gradient is negative, only from there up to there. Because it continues forever, but that's what it means, only that line. The reason I'm considering that negative line, and I'm going to equate it with this positive line here. I'm going to equate it with our line. And we know what our line is. Our line is 3x. That was 3 over 4x minus 1 over 4a. So that's what I did there. And then you will see that I will be able now to find the coordinates, right? So this is going to allow me to find the x value, and from there I will just substitute in any one of the equations to find the y value. Okay, distributing that negative over, and then you have all the terms that contain a to one side. So I'm going to have the a plus 1 over 4a. I have 3 over 4x plus 1 over 4x. Okay, if you look at this value of a here, this is 1 plus 1 over 4, that is 5 over 4a is equal to x, because it's just going to be 1x. So I know what my x value is. Right, let's bring my equation to find the y value. And I will use, which equation will I use? I will use obviously 3 over 4x minus 1 over 4a to find my corresponding y value. Alright, and if I do that, I will find that y equals 3 over 4. And what is the value of x? Well, that is 5 over 4a, right, minus 1 over 4a. Right, so if you clean this up, y will be 15, okay, over 16a minus 1 over 4a. So grab a calculator. 15 over 16, just the numbers, minus 1 over 4. What do we get? 11 over 16. Good. So therefore x, y. The coordinates of x, we know that the coordinate of x is 5 over 4a. The coordinate of y from my calculator is 11 over 16a. Now, of course, you are more than welcome to give those answers as decimals, but that does it for me. I mean, it's still, it says in terms of x, right? In terms of, not x, but rather in terms of a. That's what your answers should be. You can see both of them have got a there. Right. They are saying we should deduce something, the solution of the inequality. So let me just bring that graph. Let me bring that graph. And I'm going to take a snapshot of it. Don't worry. Just want to make a little point over here. I'm going to obviously make it much smaller. But what it means is, where is the absolute value graph above, right? Where is it above the line? It is going to be from this. Now, one of the things, maybe make it slightly bigger. One of the values I must add is that we know the intersection of the graph. We know that this particular value, we know it is the a value, which was 5 over 4a. So this is 5 over 4a. Where is this blue graph on top of the other one? Of course, it's when it's facing here. From here, this graph is on top of the other one, but not at the point of intersection. Where is it pointing to? It's pointing to negative infinity. So what is the value? X should be less than 5 over 4a. That is when the absolute value function is above the line. That's basically what it means there, and that is the answer. You had to deduce that, and you can use your diagram to help you to come to terms with that. Right, so this brings me to the end of my series of question papers for paper 2, which is based on theme 2 AS level. I will be starting soon with paper 1s, all 4 of them, which is based on theme 1. And hopefully by next week, Tuesday, I can be done with them, doing 2 per day. All right, I need also to rest. Remember to subscribe to the channel. Let's see where we're at. Subscribe to the channel, and let's push and reach 10,000 subscribers. Okay, the moment we can reach 10,000 subscribers, we will be at the right place where we need to be. Okay, and also get in touch with me, find a way how we can make this channel to grow. Right, good luck with your studies, and I hope when you do get paper 2 in 2025 exams, this is last year's paper, I've done all of them, then you can actually say, oh, you know what, Mr. Max, help me. I think I'm on the right path. Good luck with your studies.